Every time I think it's not going to ask me for my password. Okay, so crossover and integration. This is our last lecture in our unit 2. So basically halfway through our content. So we are going to discuss the crossover concept today. And we've alluded to this a little bit in past lectures, but we're really going to understand it now. So this concept describes the shift from fat to carbohydrate metabolism as exercise intensity increases. So whenever we're increasing, we know that we're going more towards the carbohydrate way. So this is due to recruitment of muscle fibers that need fuel ASAP. And as the increase in blood levels of epinephrine that stimulate glycogenolysis. So we've seen a version of this, but a little bit different. So this is our crossover concept. Really important graph to understand. So let's spend some time with this. Again, orient yourself. We're on our x-axis. We're talking about percent of exercise intensity. And we're also talking about the percentage of the contribution of total energy on our on our y-axis. So we are talking about carbohydrates and fats. So let's go ahead and look at our fats, where if we have a low exercise intensity, so a low percentage of your VO2 max, we know that we are mainly utilizing fats and not so much carbohydrates. However, when that exercise intensity increases to 100%, we know that we are using a lot of carbohydrates. And probably only about 10% fats, 10 to 0% fats. And so really what we're talking about is this crossover concept, this spot right here at just shy of about 60% intensity is when between, 50 and 60% here, is when we see 50% contribution of carbs and 50% contribution of fats at around 60% intensity. There, I finally said it correctly. I just get so excited. My mind is ahead of what I'm speaking because I just love exercise physiology. Okay, so in continuing to talk about this crossover concept, we have attempts to integrate different ways of exercise. So the literature lists like these 5 divergent effects that affect how someone performs or is good, I guess, at sports. And this is gender, age, prior training, and we've talked about these factors before, exercise intensity, and nutritional status. I'm sure you could come up with more, but this is what your book outlines. STATUS. So when thinking about this crossover concept, we also have to talk about the respiratory exchange ratio. Now, I alluded to this a couple modules ago when I showed you my VO2 max printout from my graduate school days. So respiratory exchange ratio is RER. Sometimes you'll see it as R, sometimes you'll see it as RQ, sometimes you'll see it as Q. But I think for this class, I keep everything pretty close to this RER. So this is the ratio of carbon dioxide produced to oxygen consumed. So CO2 produced versus oxygen consumed. So we're really comparing sort of this exhaled gas to room air. And we can do this through our VO2 max test or through a resting metabolic rate chamber. And so the ratio of carbon dioxide produced to oxygen consumed. I thought the schematic was sort of fun. That shows you inhaling oxygen-rich air, supplying this oxygenated rich blood from your lungs to the rest of your body, where your exercising muscles are utilizing oxygen in this form of our currency, our energy currency of ATP, then eventually coming out for exhaling of our carbon dioxide. You've seen this a few times. This is from the video from our VO2 max test. So I'm just trying to kind of show and prove that everything is related here as we're talking about this. So how can the respiratory exchange ratio, or R, be used to estimate whether fats or carbs are being used as a fuel? So that's really what I want you to understand here, is that the respiratory exchange ratio and this crossover concept, we're really discussing whether fats or carbohydrates are being used as a fuel source to fuel that activity. So what we're talking about is the estimation of fuel utilization during exercise. What kind of fuel are you using during your exercise bout? So fats and carbs, this is what's so cool. If you don't write anything down ever, write this down. This is so freaking cool. I love science. So fats and carbohydrates differ in the amount of oxygen and carbon dioxide produced. So when we are analyzing in this metabolic cart, this carbon dioxide production and the oxygen that we use, we can do that scientifically because fats and carbs differ in the amount of oxygen and carbon dioxide produced during oxidation. And I'll continue to explain this as we go through. So usually your respiratory exchange ratio at rest is about 0.78 to 0.8. So this is mainly indicating that you are using fat as fuel, just fat as your fuel source. If your RER is about 7. So what is primarily being oxidized? Fat. So if we were talking about fats at rest, or sort of that long, slow duration, your RER is 0.7. When we are talking about utilizing carbs, this means you have an increase in exercise intensity and your RER is going to be closer to 1.0. And then obviously we sort of have a mix here in the middle. And so when we talk about exercise intensity and fuel selection, we know that low intensity exercise, so less than 30% of your VO2 max, the primary fuel that we are using is fat. Whereas in high intensity exercise, greater than 70%, the primary fuel that we are using are carbohydrates. So in continuing this idea of our exercise intensity and our fuel selection, I think this table is really, really important to understand. So if we are talking about rest, let's put rest over here, and then higher intensity here. At rest, we've already said an RER of 0.7 is 100% of fats being oxidized and 0% carbohydrates. When you have a high intensity, an RER of 1, that's 0% fats being oxidized, but 100% of carbs. We know that this is a continuum. So if you have an RER of 0.85, that is when you are oxidizing 50% carbs and 50% fats. So this respiratory exchange ratio of 0.85 is that crossover, when you are using 50% fats and 50% carbohydrates to fuel that exercise that you are doing. So here we are revisiting my lovely VO2 max printout from many years ago. So I have a couple questions. Where did my crossover occur? Meaning, where was my RER 0.85? Where did my crossover occur? And what about my RER being over 1? So let me reorient you here since this is sort of off center. So these are my RER values. And so we are looking for an RER of 0.5, which is going to be right about here around the 8.5-minute mark of my VO2 max test. So we know that here is when we have 50% fats and 50% carbs. As I go through the VO2 max test, and this is how you know if an individual truly got to VO2 max, did their RER get a little bit over 1? And mine did. My RER got above 1. But you might be saying, wait, this table only goes to 1. Are you some physiological amazing specimen? Yes, but no, because your RER over 1, we'll talk about in a second. I'm going to leave that hanging. Let's see. What else do I want to talk about here? So let's go ahead and look at this last column where we are talking about this kind of mix O2, CO2. With my RER being about 0.85, let's just call it right here, we have 31.1. And my max was 47.8. If you take 31.1 and divide that by 47.8, sure enough, you get 0.65, which means that I was at about 65% intensity when my crossover occurred, which is really cool because if you go back to the initial graph, I am physiologically perfect. I wish you guys knew me and knew my personality. I don't think that, but I think that it's really, really cool how things work out. So let's visit back to what RER over 1 could possibly mean. So an RER greater than 1.0 is caused by carbon dioxide derived from lactic acid or by hyperventilation. That is why my RER was over 1. When you've had a really hard and really intense exercise bout, and you're hunched over, your hands are on your knees, and you are breathing heavily, and you are hyperventilating because you have given that particular activity your all. So hyperventilation is the reason why my RER was above 1 on my VO2 max test, meaning I truly was at my peak, my max. I couldn't have done any more. So during prolonged exercise, we know that there's this shift from carbohydrate metabolism towards fat metabolism, and this increases the rate of lipolysis. So our breakdown of triglycerides into glycerol and fatty acid, again, showing about 65% of your VO2 max for your intensity, for your exercise intensity and fuel selection. So some concluding thoughts for this, and really what the take-home messages for this lecture should be: RER is used to determine what fuel source is being used for that muscular work and activity. What is RER at rest? 0.7, where you are primarily oxidizing fats. What about intense exercise? 1.0, where you are primarily tapping into carbohydrates. Where does your crossover occur? An RER of 0.85 means that you are utilizing 50% fats and 50% carbs. What does RER over 1 mean? That means that you are in a hyperventilative, is that a word? State. So up next, our final day of Unit 2, metabolic adaptations. See you soon.